Lesson 3, I do have one change to tell you about on your agenda. If you will look at tomorrow's, just a reminder though before we talk about that, the spiral is due tomorrow. At the beginning of class, I will not take questions on it like I do homework. So any questions that you have remaining either need to be asked of me as I'm walking around during homework time or come in before school tomorrow and ask me. Okay, so when we come in tomorrow, these will be due. This homework here, gentlemen, it says it's due Tuesday, but we'll actually finish up this lesson on Tuesday, so this is actually due Wednesday. Okay, so you might want to make that change. And that will be due on Wednesday. All right. Okay, so next we're going to start lesson P3. And hopefully this one will be a pretty easy review. This is about linear equations and inequalities. Linear equations and inequality. Okay, I'm going to jump right in with an example here. How would you prove to me that x equals negative 2 is a solution of x cubed minus x plus 6 equals 0? And when I say prove, I don't mean like a 2-column geometry proof, like with given and reason and that kind of stuff. Just algebraically, how would we prove that that is a solution? Sub it in, okay? If you need a calculator, grab one, but I think we can do this one without. Okay, so I'm not asking you, is this a solution? Basically, I'm saying it is, just verify it. Okay, so when I sub it in, I should get 0. What is negative 2 cubed? Negative 8. When I subtract a negative 2, that becomes plus 2. And then I have plus 6. Negative 8 plus 2 is negative 6. Plus 6 is, in fact, 0. So that is how I would prove it. Just sub it in and show that it actually makes the statement true. Okay? All right, what is a linear equation? How would I know if I have one or not? Is this a linear equation? How do you know? What's the dead giveaway there? The cube. Okay, x being cubed, that is not linear. If I took that away, would that be linear? Yes. Okay, so a linear equation can be written in the form ax plus b equals 0. Or you could even change it to mx plus b equals 0. Because the coefficient in front of a would be considered a slope if it was equal to y and not 0. Okay, where a is not 0. Why can a not be 0 there? If a is 0, what goes away? Or even more than that, the whole variable, right? So if a is 0, then I just have a number equals 0. So, of course, a can't be 0. All right. So, these are some examples that are not linear. X squared plus 3 equals 0. That would actually be called what instead of linear? Quadratic, because the exponent is 2. Something with a cube, or a power of 4, or 5, or 6, or anything 2 or larger as your exponent. Something with a root, that's not linear. It's actually called a radical equation. Something where x is in the denominator is not linear. Okay, so things like that are not linear, so just be on the lookout for those. Their graphs would not be lines. They would be other shapes. Okay, example 2. Solve for x. 5x plus 2 equals 2 times 2x minus 3 plus 3 times x plus 1. Okay, I'm going to let you work through that. I'm going to freeze my screen and I'll work through it too, and then we'll compare. Because this, I mean, you've been doing these for years, right? We're just trying to get those wheels turning again. So I'm going to freeze this. And we'll work them individually. You can talk to your neighbor about it, compare, and then we'll all compare at the end.
X is 2.5.
2.5. Anybody else have an answer that's different? A different version of that number? 5 over 2, 2.5. Okay, here is my question for you. This is always interesting to me. So if you missed it, if you made a mistake along the way, find it. Ask me if you can't find it. When you got down to this point, you had to make a choice. Am I going to collect x's on the left or on the right? And there's always two groups of people. Raise your hand if you are that person that no matter what, you're going to collect x's on the left. Just? Okay, a few. Okay. How many of you decide based on the equation and you collect it wherever it's going to be positive? Wow. Usually it's about half and half. Okay. I usually collect on the side that will be positive, but I didn't in this case. I just collected them on the left. So it's funny though, because some people are like, nope, you collected on the left every time, no matter what. Okay, any questions on where that answer came from? A mistake you made that you can't find? Okay, piece of cake. All right, example 3. Let's crank up the difficulty just a tad and throw some fractions in there because you guys love fractions, right? Are they that bad? Okay, I'm going to leave a little space here. 5y minus 2 over 8 equals 2 plus y over 4. Okay, so 2 of my 3 terms are fractions. I would at least think of this third one as being a fraction by putting it over 1. Okay, so here's the deal. I think it was Baden who groaned when I said fractions, because sometimes they do add to the difficulty of a problem, right? Sometimes it's easier if we can get rid of them, which is exactly what we're going to do here. So when I say I'm going to get rid of them, I'm not just going to toss them out, but I'm going to multiply this equation by something that makes them go away. And that is called the least common multiple. So I'm looking for, look at all your denominators. What is the smallest number that 8, 4, and 1 will all divide into? 8. Okay, so this is what's confusing. The greatest common factor among those is 1. The greatest common factor among 8 and 4 is 4. But the least common multiple among all of them is 8. So think about this. I'm looking for a number that all these will divide into evenly. Now, I could use 32. I could use 64. There's lots of numbers I could, but to make it easy, you want to find the smallest one that'll work. Okay, so that number is 8. So I am going to multiply the entire equation by 8. And if you prefer to think of that as a fraction, that's 8 over 1. Okay, so what you do to one side of an equation, you must do to the other. Okay, so when I multiply 8 times this fraction, what's happening to those 8s? They will cancel. Okay, so what is left behind is just a 5y minus 2. That's so much easier to deal with. Okay, this 8 distributes here. When 8 is multiplied by 2, then that's just a 16. Nothing's canceling. I'm just multiplying and distributing there. But when 8 multiplies this fraction, then the 8 divides by the 4 and becomes a 2. So this becomes 1, this becomes 2. I just simplified the fraction 8 over 4. And then I have 2y. Okay, that's a baby equation. No fractions. Really simple. Go from here and let's find y. You find it, I'll find it. When you get your answer, check up here.
Why did you take the 4 out after you distributed it to 2?
This 4 here?
Why did you multiply the 8 by the 2 and then why didn't you do the 4?
So this right here is really y over 4 times 8 over 1. And so I just reduced that fraction and made it a 2. So I really just had y times 2.
Why didn't you do that first instead of...
Over here?
No, why didn't you do that before you multiplied the 8 by the 2?
I could have, but both of these are becoming, are getting multiplied by 8, so it doesn't matter which one of these you did first. They'd both just be over there on the right-hand side. I didn't answer your question, did I?
Could you have simplified it before you did anything? Is what I'm trying to ask.
There really wasn't any simplifying. You mean these two here? Come show me on my paper. All right, I'll get back with you. We'll sort it out in a second. Okay. All right, let's do another one with fractions. While we're working on this one, I'll come over. You can show me what you're talking about. Okay, so this one, all 3 terms are fractions. I would really like to get rid of the fractions, so I'm going to multiply by the least common multiple. What is the smallest number that 8, 2, and 3 will divide into? 24. Now, what happens if you don't recognize 24 and you use something bigger? You'll still end up with the same answer in the end. You'll just have a little more reducing to do. Okay, so we're going to multiply. I'm just going to put one of these brackets. Everything in the equation gets multiplied by 24. Okay, so this term, and that term. Okay, so let's look at this. Just that first term and the 24. When I multiply 24 and I see an 8 in that denominator, what happens to that? 24 divided by 8 is 3. Okay, so I really have a 3 times t plus 5. Okay, when I multiply that middle term by 24, and there's a 2 in the denominator, 24 divided by 2 becomes 12. Now be careful with this minus here. I'm I'm going to still have the subtraction. I'm just putting the 12 in front of the quantity t minus 2. Okay, then when these two multiply, it's just 24 divided by 3, which is 8. Now, that's a pretty simple equation. Okay, so go from there, do your distributing, collect your like terms, and find t for me. So because this is technically number 1, I can't just make that denominator 4. So I can make this be 8 over 4.
Well, I'm talking about this. Like, could you not have simplified it before you touched any of this, and then that would be 4?
Because you're thinking. I see. Okay, I'm with you now. Okay, so I could do it that way if this was also over 4. But since it's not, I have to individually distribute there. So when I distribute 2 times 2, that is 4. I'm sorry, I have to distribute the 8. So 8 times 2 is 16. 8 over this, that reduces to 2. If this was over 4, then I could do that reducing and just distribute. It's just because this is over 1. Okay, because we put a little over 1 right there for me. So it's really 2 over 1 is still 2. But here, 24 over 2 becomes 12. So because this denominator didn't reduce with the 8, that's why I've taken it. 8 divided by 4 becomes 2. Over here, 8 divided by 8 just becomes 2. Okay, sure. All right, let's see what we get here. This will be 3t plus 15. Be careful with your distributing a negative. We tend to make careless errors when we do that. That gives me a negative 9t and a 39. And then I'm going to subtract 39. Negative 9t is negative 31. Divide by negative 9. Not a pretty number, but I get 31 over 9. Any questions on that one? What? Okay, let's do another with fractions here. Example 5. 3 minus 4x over 6 minus 2x minus 3 over 8 equals 2 minus x. Okay, if you want to think of this as a fraction, that's over 1. Again, to get rid of denominators here, to get rid of those fractions, I need to figure out what that least common multiple is and then distribute that to everything. So 6 and 8, what's the smallest number they'll both divide into? 24 again. Okay, let's take everything and multiply by 24. If you prefer writing that as a fraction, then it's 24 over 1. Okay, distribute and let's see what you get. I'm going to turn my screen back on, just make sure we reduced correctly before we go further. Maybe. Hello? You gotta be right in front of this dang thing. Okay. Did you reduce correctly? I haven't distributed yet. Did you reduce correctly? Anybody have a question about any part of this? Okay, now distribute. Okay, no rush, but when you finish, check up here. Who has a question? Anybody have a question? Nathan, you good? Okay. I thought you were trying to find a mistake. Got it. All right, so let's switch gears just a tad bit and talk about linear inequalities. Okay, so a linear inequality can be written just like an equation, but instead of just an equal sign, it'll have a greater than 0, or a less than 0, or a greater than or equal to, or a less than or equal to. So you're just replacing the equals with something that involves greater than or less than. Okay, but the way we solve them is pretty much the same, with one little exception. What is that little annoying rule when you're dealing with inequalities that you have to sometimes remember when you're dividing or multiplying? Anybody, come on. Not keep, change, flip. If you divide by a negative or multiply by a negative, you have to switch the sign. Okay, so when multiplying or dividing an inequality by a negative, you must reverse the inequality. Oops. I crossed my L there. Should be inequality. I keep thinking I can lean on this. Okay, so the reason is, let's take 6 is greater than 3. We all agree that's right? Okay, if we multiply both sides by 2, then 12 is still bigger than 6. But if I take that 6 is greater than 3, and I multiply both sides by a negative 2, I get negative 12, and I get negative 6, and negative 12 is not bigger than negative 6. Negative 12 is less than negative 6. So multiplying or dividing by a negative totally changes the statement, and we must reverse the inequalities. That's the only real trick to these you have to remember. Otherwise, we treat them exactly like we treat equations. Okay, so example 6, let's throw an inequality in here. And we're going to solve 3 times x plus 1 plus 2 is greater than or equal to 5x plus 6. Okay, so solve that for me, just like it's an equation, unless you multiply or divide by a negative. Okay? Now, I will join team always on the left side with inequalities. I will always bring my x's to the left if it's an inequality. Check up here when you're done. Make sure I didn't make a mistake, because I will make plenty and I make the same dumb mistakes y'all make. Add things wrong, multiply things wrong. Okay, so turns out on this one I did have to divide by a negative, so I had to switch it around. Now, if you kept your variable on the right, then you ended up with negative 1/2 is greater than or equal to x. Did anybody end up with that? Okay, that's not wrong. But if I ask you to shade a number line, to me that's just a little more difficulty than it needs to be. Negative 1/2 is bigger than x. So if I were shading a number line or writing an inequality, an interval notation for it, this to me seems much easier. But it's certainly not wrong, it's just as correct as the other. Okay, so let's do the interval notation. What would this be in interval notation? X is less than or equal to negative 1/2. What's the smallest value of x that would make this true? Negative infinity. What is the largest? Negative 1/2. And because there's an equal to, then I will use a bracket there. Okay, so you could write your solution as either. To me, it's a little bit harder to write that one in this form. I would have to switch it around. All right, so are we okay on that one? Either is right. Yep. Okay, on the next one, we're going to throw in the inequalities and the fractions together. Of course. Okay, so we've got fractions to deal with and the inequality. Okay, so the first step I want to do is get rid of my fractions. Okay, look at your denominators. What is that least common multiple that they will all divide into? 12. I'm going to multiply every little thing by 12. Okay, so distributing and multiplying 12 by this very first fraction, that's really a 12 over 1. So 12 divided by 3 becomes 4, and it'll be multiplied by the x. Okay, moving on to the second fraction, 12 divided by 2 is 6. 6 times 1. Still greater than, I'm not multiplying by a negative. 12 divided by 4 is 3, so I have 3 times x plus 12 divided by 3, 4 times 1. Okay, so now I have 4x plus 6 is greater than 3x plus 4. Okay, I'm going to collect those on the left. I think we all would because that's also where it will be positive. X plus 6 is greater than 4. Subtract 6 and get negative 2. And that's it. Interval notation would look like what? Good. Question? Pardon me?
Why is the infinity on the other side?
Because think of a number line. If I shaded greater than or equal to negative 2, I would have negative 2 down here, and I would shade this way. So infinity is the biggest number that's shaded. Okay, parentheses is used with infinity always. But as far as the numbers go, if there's not an equal to, then we use parentheses. If I had an equal to, like I did up here, then I use brackets. So bracket means include the number. Parentheses means don't include it. Okay. Any other questions? All right, I've got 2 more for you, and oh dear, I could probably finish this. All right, I'll just give you some time to work on homework then. Sample 8. Oh wait, this is the whole lesson today. Yeah, scratch that. Okay, 1/3 x plus 1/4 is less than 1. 12 is definitely. Let me say this though. There are 2 ways I can start this one. One is to multiply by 12. Do you see another way that I might start this one that I didn't on the others? Yes, since I just have one number on this side, which was not the case with the other ones, and this is just a number, I could combine those first. I'm still going to multiply by 12 in the end, so I'm just going to go ahead and start out that way, but if you prefer to combine the 1/4 and the 1 first, you can do so. Okay, so multiplying everything by 12. Okay, so what's 12 divided by 3? 4 times 1x is just 4x. What's 12 divided by 4? Times that 1 is 3. And 12 times 1 is 12. Let's finish that one out. I'm going to subtract 3. Get 4x is less than 9. Divide by 4 and get x is less than 9/4. Okay, so if we picture a number line, that's an open circle on 9/4 shaded to the left. All right, so Evan, what would that be in interval notation?
Parentheses, negative infinity, comma, 9/4.
Good save. Okay, question. All right, I think we just have one more example and then you get homework time or factoring finish up time. All right, solve. What? Does anyone know what this is called when I have more than one in a statement? This is a compound inequality. It's just 3 combined in one statement rather than your normal 2. So compound just meaning more than 2. Okay, but I'm going to treat this exactly like I did the others. I'm going to leave them as a compound statement, but I'm going to do the same thing to all 3 parts, whatever it is I'm deciding to do. Okay, so notice that the x is in the middle here. Let's chip away until x is by itself. So look at this fraction right here. What would you do to both sides, to this fraction to get x by itself? Multiply by 3. And that is also the least common multiple if you think about putting those over 1. Then 3 would be your least common multiple. Okay, so I'm going to multiply everything by 3. And again, the only reason I'm using 3 is that's the denominator. Okay, so I just have 1, 2, 3 things to distribute now. Okay, so negative 3 times 3 becomes negative 9. I'm not multiplying by negative, so it's still less than. What happens when I multiply these? Yeah, the 3's cancel, and I just have a 2x plus 5. Less than or equal to 15. Okay, so I want x by itself. What would you do next? Subtract 5. But guess what? I've got to subtract it from all 3 parts. 3 sections, they all get treated equally. So now this is a negative 14 less than 2x less than or equal to 10. One more step to get x by itself. Divide by 2. But all 3 parts get divided. So this is negative 7 is less than x is less than or equal to 5. Okay, so if I were shading a number line, I would have an open circle here, a closed circle on the 5, and shade between. If it's interval notation, I'd have parentheses negative 7, comma 5 bracket. Include the 5, don't include the negative 7. Question? You have loads of time to work on your homework then. Okay, so this homework is due tomorrow. So we're starting a new lesson tomorrow. So homework and the spiral are due. So even though you have loads of time, you have a good bit of work to get done. Homework, check for accuracy. The spiral, factoring, check for accuracy, homework for effort. Yeah, let me stop this recording and then I'll come back.